Hello everybody and welcome to Notes 6.8. So today we're going to be graphing radical functions. So if you have been learning your transformations this whole school year, this is going to be a breeze for you because transformations are used for all different types of graph. The only thing that changes is the parent function. So that's what we're going to be doing today. So graphing radical functions. So it says a radical function is any function that can be written in the form of f of x equals a, the nth root of x minus h plus k, where a is equal to 0. For even values of n, the domain of the radical function is the real numbers x is greater than or equal to h. This function can also be known as a square root function. All right, but it's not necessarily always going to be a square root. We could have a cube root, a fourth root, etc., etc., etc. So some examples of this is I would have f of x is equal to square root of x minus 2. We might as well just talk about our domain while we're here. So this graph is going to go ahead and move right to. Remember, when it's inside our function, it's always opposite of what we think. So this graph is going right to. So normally our parent functions go from 0, 0, and the radical function looks like this, from 0, 0. So since we're going to be going right to, that means the domain is going to start at positive 2 and then go towards infinity. So x is greater than or equal to positive 2. I usually don't use inequality notation. I actually like interval notation better. So for this domain, it would start at positive 2 included, so that's why we use the bracket, and it would continue towards infinity. Let's do another example. Let's do f of x is equal to 2 square root x minus 3 plus 1. You know what? Let's make this a plus 3, just so we can look at a different domain. So we should know what's happening to this graph. The 2 is a vertical stretch by 2. This is going to go left 3, up 1. So the up 1 is going to end up changing my range, but we're just going to go ahead and talk about the domain right now. So this domain is going left 3, so it's going to start at negative 3 and then go towards infinity. So we have domain from negative 3 to infinity, again with a bracket around the negative 3 because it is included. And we'll get into more of this. Okay, so we're going to talk about the square root function and then the radical function. So parent function means that there's no stretches, no shrinks, no lefts, no rights, no any of that stuff, ups, downs. So it's your parent, it's your base function. So our parent square root function would just be y equals square root of x. Our radical function would just be y equals the nth root of x, whatever root this is, a cube root, fourth root, yada, yada, yada. Okay, so to have a reflection in the x-axis, so to reflect across the x-axis, that's where we have that negative out front. So we would have y equals negative square root of x, or y equals negative nth root of x. So that's going to reflect it across the x-axis. It's not on here, but we should talk about it. To have a reflection across the y-axis, the negative is on the inside of the function. That will reflect across the y-axis. Stretch, remember, so a stretch is when a value is greater than 1. A shrink is when a is between 0 and 1, so like a half, a third, yada, yada, yada. So we get y equals whatever a is, square root of x, or y equals a nth root of x will give me that stretch or shrink depending on the a value. And then our lefts, rights, ups, downs. So horizontal is h, and then k is our vertical. Remember, horizontals are inside the function, verticals are outside the function. Inside the function, it's opposite of what you think. Outside the function is same as what you think. So this would go y equals square root x minus h, opposite, and then plus k, same as what you think. Same here, y equals the nth root of x minus h plus k. All right, so let's go ahead, graph our first one. What I want to do is I really want to show you guys what the parent function is, and then we're just going to use transformations. I'm not a huge fan of t-charts. I think they're a waste of time, but t-charts do always work, so when in doubt, you could always use a t-chart. But I'm going to just teach you how to take your parent function and then use the transformations to transform that parent function. So let's start by making a parent function. So we're going to do y equals square root of x. We'll make a t-chart for this so we can get that parent. Okay, so remember x, just notice here, x has to be positive. If x is a negative number, the square root of a negative is imaginary, so it's no longer real. So we have to pick positive numbers, but we can also use 0. So the square root of 0 is 0. Square root of 1 is 1. Okay, let's pick something nice. Square root of 2, I don't know. Don't pick it. Square root of 3, don't know. Don't pick it. Square root of 4, I do know. Square root of 4 is 2. Square root of 5, don't know. 6, don't know. 7, don't know. 8, don't know. 9, I know that one, which is 3. Okay, let's go ahead and plot those points. I'm going to make this guy purple. He's going to be purple. So we have 0, 0, 1, 1, 4, 2, and then 9, 3 is off the paper. Go ahead, connect these. Okay, so let's talk about this function for a second. This function is the inverse function or the opposite function of a quadratic. I couldn't think of that word. Of a quadratic, okay? Because we square root something, so when something is squared, we square root it. They're opposite functions to each other. So notice this graph right here, if I were to draw the other side, gives me a sideways parabola. And we know a quadratic function gives us a parabola. So this is still just a parabola switched on the side, and it's only half of it to keep it all real. So this is also going to follow the 1, 3, 5 that we use for graphing quadratics. So instead of over 1, up 1, over 1, up 3, over 1, up 5 for a quadratic, it's the opposite. We're going to go up 1 over 1, up 1 over 3, up 1 over 5, up 1 over 7. So it still follows that 1, 3, 5 pattern that we know. But now it is moving, that 1 through 5 is going horizontally instead of vertically. Okay, so that's my parent function. And now, based off of that parent function, we can just use our transformations to graph our next one. So this guy right here, oh, we can keep using blue. This plus 2 on the outside, that is a vertical shift, and that is telling us to go up 2. So all of these points are literally just going to move up 2. So we're going to have up 2. Next one will go up 2. The next point's going to go up 2. So here is my final graph, and I do that with a solid line to show that that's my final graph. I'm going to go ahead and highlight that since I have similar colors out there. So this guy is my final graph. Okay, so again, with graphing, we really want to know how our parent function works. Parent functions always go through 0, 0, so this one starts at 0, 0, and then I go up 1 over 1, up 1 over 3, up 1 over 5. Okay, it's always going to have that shape. It's always going to look like that, a square root function. This is for a square root function. All right, so let's look at this guy. So this guy, looking at our transformations, this is telling us to go down 3. So we're going to take our parent function and move it down 3. So remember, it goes like so. So here's my parent function. I went up 1 over 1, up 1 over 3, up 1 over 5, and we're going to take those points and move them down 3. So all of those points move down 3, and this is my final graph. So hopefully this is really easy because we know our transformations. The only new thing you're learning is that parent function. All right, so let's look at our next guy. The minus 3 is on the inside of the function. It's inside the radical. Anything on the inside is horizontal, and anything on the inside is opposite of what you think. So this is a horizontal shift, and this is going to go right 3, opposite of what we think, right? I see minus 3, I think left, but it's actually right. So we're going to go right 3. So again, we're going to take our parent function. So there's my parent. And we're going to just take all those points right 3. And connect our dots. And voila. All right, let's try the next horizontal one. Plus 2, it's on the inside. It's opposite of what I think. It's horizontal. So this is going left 2. So we take our parent function. So remember, it goes 0, 0, up 1 over 1, up 1 over 3, up 1 over 5. We're going to take that, and we're going to shift everything left 2. And here. Remember, this should have like a nice arch. It is a sideways parabola, half of a parabola. So it should have that same curve, that same shape. Yeah. Okay, next page. Okay, so now we finally get to combine some of our transformations into one. So let's just talk about all of these different things that's going to happen here. So the first thing let's talk about, let's get some new colors out here. I'll do baby blue. Oh, I already used baby blue. Let's do green. Okay, so we have this 2 that is on the front. Okay, so 2 is being multiplied. Anything that is being multiplied to our function is stretches or shrinks. Okay, this is greater than 1. It's on the outside, same as what I think, greater than 1. So this is vertical. Everything on the outside is vertical. Vertical stretch by 2. Okay, next thing we're going to go ahead and talk about is this guy. It's on the inside, opposite of what you think. So this is going left 3. And this shift right here, it's on the outside. Everything on the outside is vertical. Everything on the outside is same as what you think. So that's going to give me a down 1. Okay. We're going to start with our parent again. So again, 0, 0, 1, 1, 4, 2. That is my parent function. Okay, so on parent functions, when you are using your transformations to graph these, you guys always want to stretch, shrink, and reflect first. And then the last thing you do is shift it. So I'm going to go ahead and stretch by 2. I'm vertically stretching my distances. So you're taking these vertical distances, and you're going to double them. They're multiplying by 2. Okay, 0, 0 has no distance, so that's going to remain 0, 0. But then this next one, this has a vertical distance of 1, so I'm going to double it and put it up here to 2. Okay, my next point has a vertical distance of 2. We're going to double that to 4. Okay, so this still isn't my final graph, so I'm still going to make it a dashed one, showing that it's not my final. So this was my vertical stretch by 2. Okay, so now that we've stretched it, the last thing to do is shift it. So now we're going to take that stretch one, that green graph I just made, and we're going to go left 3, down 1. So we're just going to take each point, left 3, down 1. So take 0, 0, I'm going to go left 3, 1, 2, 3, down 1. So I'm at negative 3, negative 1. My next point I have is 1, 2. So we're going to go left 3, 1, 2, 3, down 1. So my new point is at negative 2, 1. Next one we're going to take is that point 4, 4. We're going to go left 3, down 1. So now we should be at 1, 3. And I can actually fit the next one. So remember, it follows that horizontal distance is 1, 3, 5. So I'm going to actually go up 2 since it was vertically stretched by 2. So from the point 1, 3, I'm going to go up 2 and then over 5. 1, 2, 3, 4, 5. So I have another point that fits on our graph that is going to be at 6, 5. All right, we're going to connect our dots. Only one side is continuing, so you need to have that arrow. 0, 0, or like the original 0, 0, there's no arrow right there. That's where it starts, so it's just a point. And then it's continuing towards positive infinity forever and ever and ever and ever. Let's go ahead and state the domain and range of this, just to get some variation here. So our domain is our x values. So you look at your x-axis, you always go left to right, and we start on the left, and we find the first spot that there's an x. So right here at negative 3, there is an x value, and then it continues in this direction forever because of this arrow. So it continues forever and ever and ever and ever and ever. So my domain is including negative 3, and it's going towards infinity forever. Remember, on infinities, you always use parentheses. It cannot be bound. You cannot say what infinity is. So it keeps going. Okay, range. Range, we go bottom to top. It's your y values. So start at the bottom. So you're like looking at y values, y values, y values. The first y value I hit is here at this negative 1. And then these y's are going to keep continuing because this is going to keep growing higher and higher and higher and higher forever and ever and ever. So it's going to go from negative 1 to infinity. Again, this is a closed dot, so negative 1 is included. So then we have from negative 1 to infinity. All right, next one. Ooh, taking it even a step further here. So we got a reflection in here too. I know we have a reflection because of that negative. So let's list out all of these bad boys. Let's get a new color for this reflection. Let's do orange. Okay, so this right here, I guess I'll go this way. This is a reflection. Remember, negatives are reflections. Negatives that are being multiplied are reflections. It's on the outside, so this is a vertical reflection. So it is flopping over the x-axis. It's flopping vertically. So this is a reflect across x. Okay, then we have our 1/2. So still on the outside, same as what we think. So this is a vertical shrink by 1/2. All right, and then let's do our shifts. So this guy is on the inside. It's horizontal, opposite of what you think. So this is a shift right 1, and this guy right here is a up 4. All right, so I'm going to do all these transformations. So again, we're going to start with that parent, 0, 0, 1, 1, 4, 2. Okay, so here's my parent. It's dashed. This is not my final graph. Okay, so remember you want to do reflections and stretches and shrinks first and then move it very last. So I'll go ahead and start with the reflection. So I'm reflecting across x. So that means these points are going to be reflected across that x-axis. Okay, so this would be my reflection. And look, it's a full parabola now, a sideways parabola. Okay, so that's my reflection. Next, I'm going to go ahead and shrink it by 1/2. Remember, this is vertically, so this vertical distance is going to be cut in half. So let's go get to my color, green. So it's still at 0, 0, cutting this distance in half, and cutting this distance in half. So this is my vertical shrink. So there's my vertical shrink. Vertically it got squished. And now the very last thing we do is we move it. So we're taking each point, we're going right 1, up 4. So we're going to start here. So I'm going to go right 1, up 4. So to here, right 1, up 4. Okay, next one would be shrunk by a half, so it's right there. And my last one would be here. So I just took all those points, all the green points, and I moved right 1, up 4. Connect our dots. Remember, this end needs an arrow. That one will continue forever and ever. And this is my final graph. Okay, let's go ahead and label what all of these were, just so we don't get confused. So this was my shrink by a half, and then that orange one was my reflect across X. Beautiful. All right, so those are square roots. This guy we're going to go ahead and skip. So now we're on example 8. Now we're going to do cube roots. You will only be expected to do cube roots and square roots, know how to graph both of those in this class. We don't go higher than that. So cube roots, square roots. All right, so let's go ahead. Let's just do a quick review of cubes. Yeah, and I'm going to erase it. Okay, let's just review our cubes, just a normal cubic function real quick, and I'm going to erase it just so I can visually show you guys what or how we get this stuff. So remember, on a regular cubic function, we have 0, 0, 1 cubed is 1, 2 cubed is 8, which would be way up here. Negative 1 cubed is negative 1, negative 2 cubed is negative 8, which would be way down here. And then remember, we connect, and it snakes through those points, like so. Okay, so the cubic function is going to have this similar shape, but it's going to be reflected across the line y equals x. So across this line, it's going to be reflected. Okay, so what's going to happen is the shape is now going to go like this, and then this way, like so. So that's going to be our cubic function, and I will go ahead and show you guys that. So let's reset this page. There we are. Okay, so we have this cubic function. So the parent cubic function goes 0, 0, 1, 1, negative 1, negative 1. Our third point would be 8, 2, but that's not on our graph. Okay, the way I remember which way this curves is it's going to have that same shape as the normal radical, so it's going to look like this. The only thing I'm going to tell you to be careful about, do not let this line cross this one until 8. So it needs to just kind of go right along that 2 line until it hits 8. If you draw this and you cross that, you are incorrect. So it's just going to kind of go right along it. Once we hit 8, that's where it would actually cross it. It's very steep, sideways steep, I guess. Okay, so then the back end of this is going to curve the other way, and same thing, it's going to go right along that negative 2. Don't cross it because then you are wrong. So that is the shape of our cubic radical. So I'm going to go ahead and make this dashed. You guys get the idea here. Okay, so that's my dashed one because it's not my final one. So the 3 main points, again, that I check for is this, and then do you have the shape correct? So these 3 points, and then shape. So the reason that you have negatives on this one is because you're allowed to have negatives inside a cube function. I know what the the cube root, there we go, I couldn't think of that word. I know what the cube root is of negative numbers. So like the cube root of negative 8 is negative 2. The cube root of negative 125 is negative 5. You're allowed to have negatives in those cubic roots. So that's why our domain on this guy is just from negative infinity to positive infinity. So let's just talk about our transformation here. And let's pay attention. This is a cube root. That's how I know it's a cube root. So this minus 2 inside the function, again, that's horizontal and it's opposite of what you think. So this is just going to take it all right 2. So right 2, it will always have these 3, and then make sure your shape is correct. So again, we're going to go like this and like this. All right, let's see if that other one would actually fit on here. So it actually might fit. It's a distance of 8 from like the middle. So 1, 2, 3, 4, 5, 6, 7, 8. So there actually would be a point right here. And this is where it would cross at. Like so. All right, last little guy here. Oh, I love this one because you guys get so confused. This 1 in the front just seems to confuse us. So we're going to go ahead and rewrite this how you guys would normally see it. So that is just saying y equals negative 1/2 cube root x plus 3. And that 1 in the front just means a plus 1. Okay, let's talk about all these. So the negative on the outside, this is a reflect across x. The 1/2 is a vertical shrink by a half. The plus 3 is going to go left 3 up 1. My handwriting got real ugly right there, but that's okay. All right, so we got a lot to do here. So let's start always with our parent function. 0, 0, 1, 1, negative 1, negative 1, and then the correct shape. Okay, that's my parent. We're going to go ahead and reflect it across x. So you're going to just take each piece and reflect across x. So this is still going to stay 0, 0. This guy right here is going to reflect across x to here. And then this one's going to reflect up to negative 1, 1. Okay, so now take your new shape, reflect it. Like so. And it looks like DNA strand to me. Okay, so that's the reflection. So this is my reflect across x. Okay, now we're going to vertically shrink it. So this distance of 1 is going to become a half. This distance of 1 is going to become a half. So this is now here, and now it's approaching the 1 and the negative 1. So it's like this. Approaching the 1 and the negative 1. Like so. So this is my shrink by a half. And then the last thing we do is we're going to go left 3, up 1. So take left 3. 1, 2, 3, up 1. So at negative 3, 1 is going to be my new center. Okay. And then we would have a point here and a point here. I do think we could actually graph one more point. It would be a distance of 8 from the middle. So this is the middle. So we'd have 1, 2, 3, 4, 5, 6, 7, 8. So right here at the 5 would be where that's going to cross. And hopefully I didn't make a mistake on that. All right, let's connect it. Solid line. This is my final graph. So this guy has this shape, and this guy has this shape, like so. And that would be our final cube root. Ooh, love this question. This is a great question. All right, so the way this is written right now, some of you guys are going to try graphing, and you're going to be like, wow, it's not even going to fit on my graph, because you're thinking, well, this is going to go left 32 and then down 2. Okay, remember always, every single time on any of these functions, when graphing to see the transformations, on the x, there has to be a 1. So you have to factor out this 8 to see the true transformations of this graph. So that's what we're going to go ahead and do, is factor out the 8 to see the transformations. So we're going to get y equals cube root of 8, and then we would have x plus 4 minus 2. Okay, these are being multiplied together inside of that cube root. So we could actually separate this. We could do cube root of 8 times the cube root of x plus 4. Why would we want to do that? Well, we would want to do that because we actually know the cube root of 8. So we can take it out. So we end up getting y equals cube root of 8 is actually 2. Cube root of x plus 4 minus 2. And now this is all stuff that I know how to handle. So we have, and I'm just going to do it all in one this time. We have a vertical stretch by 2. This is going to go left, opposite. Left 4, and this guy is same as what you think, down 2. All right, so like my center, my 0, 0 is going to go left 4, down 2, left 4, down 2, so that's right here. But so normally, on a normal one, we go over 1, up 1, over 1, down 1. So it's these 2 points, but this distance is going to be stretched by 2. So now we're going to go over 1, up 2, and left 1, down 2 to get that stretch in there. So we would be here and here. Could I get another point? I think I could. It's going to be a distance of 8 away. 1, 2, 3, 4, 5, 6, 7, 8. And then still with that 2. So we would have a point right here. And I just lost where I had that at. I think it was at 4, 2. 4, 2. All right, connect it. So this piece is going to arch and go like so, and this piece would go this direction. Arrows on both ends. This is a cube root. We can have all the negatives, all the positives. So cube roots have domains and ranges of negative infinity to positive infinity, all real numbers. All right, and that's going to go ahead and conclude our notes for lesson, I think we're on what, 6.8. Everybody have a fabulous day, and I will see you guys later.